Okay, so then moving along to page 328, we have some vocab, again, that we've kind of already gone over. Nonlinear functions are functions whose rates of change are not constant, and their graphs are not straight lines. So in examples 1 and 2, we see two tables. In the first table, the x values go up by the same amount, the y values go up by the same amount. So we see that the rate of change is constant, so it is a linear function. In example 2, we see that it does not change by the same amount. If it does not change by the same amount, it is non-linear. Now notice it's still a function. Each of our x values is different, so it is a function, it just isn't linear. So in Got It A and B, it asks us to determine if it's linear or nonlinear. Again, these are both functions. A function is just something where all the x values are different. So we're good there. We just need to know if it's linear or not. So in A, from each x value to the next, it looks like it's plus 5 each time. For the y values, it looks like minus 4, minus 4, minus 4. Because the x values change by the same thing each time and the y values change by the same thing each time, A is linear. It has a constant rate of change. Now in part B, let's take a look. This goes up by 2, up by 2, up by 2. So x checks out. That one's good. Here, this goes up by 2. This goes up by 6. And this goes up by 10. So right away we see y is not changing by the same amount each time. So it is nonlinear. So I'm going to go ahead and put nonlinear. My explanation is y changes by different amounts. Or I could say y does not change by the same number. It changes differently each time. Went too far. So on page 329, they have us do the same thing with a real world problem. Here they're talking about calories in a tiger cub, and they're asking us, is it linear or not? So again, looking through it, we see that the age is going up by 1 each time. And here, now notice here, to find the difference, they're doing 1,000 minus 825. That means it went up by 175. Here, they're doing this one minus this one. It went up by 185. I could keep going, but I can already tell. This is all I needed. I can already tell that it is nonlinear. The reason it's nonlinear is this is not the same number. So it's not going to be a straight line. We'll come back for part C in just a second.